classes tomorrow.
Uh-huh.
And so I have 3 inverse problems I still don't fully understand how to do.
Okay, give me the first one.
Okay, so it's y equals x raised to 3/5 minus 3.
Like that?
Yeah, is it minus 3? It's just not showing up.
Oh, really? Not showing up on your screen?
It's, yeah, okay, there it goes. It was just not showing the minus sign.
Oh, okay. I wonder if it had anything to do with me using blue. But, okay, so what's the first step for finding an inverse?
Isn't it
There's 2 steps.
switch x and y?
Yeah, there's 2 steps. I find, and you can do them in either order, but I find it easiest to just go ahead and switch the variables as the first step because that's really simple to do. And then there's only one other step. What's the second step?
Get y by itself.
Solve for y, exactly. With that goal, what's my next line?
It would be just x plus 3 is equal to y to 3/5.
Now, how do I make that just y?
Don't you have to take the log of it?
No. You only would have to invoke logs if the variable was in the exponent. Okay, we don't have a variable that's in the exponent here. In other words, if I had something like 3 to the y, then I might have to take logs to get that y down. But that's not the case here. There is one step, quite simple step, for turning the right side of this equation into y. What do I have to take it? What power do I have to raise it to?
The 5/3.
There you go. Since I do it to the right, I got to do it to the left. So my answer is x plus 3 to the 5/3 equals y. That's the inverse function.
All right.
And all inverse problems are solved exactly this way unless you get one of the more difficult. If you get a quadratic on one side, that's going to be a little bit harder. But you may or may not have that degree of difficulty. What's your second one? Mitch, you still there?
Oh, yeah.
I think I lost you for just a second.
Yeah, I cut out for a second.
Okay. What's your second problem?
F of x equals x squared minus 14x plus 49. And then x is greater than 7. Greater than or equal to 7, actually.
Trying to find the inverse of this?
Yeah.
All right. Well, this is indeed a quadratic. And now let's do our first step. Now, I think there's probably a couple of ways to do this. In this particularly, because I can represent this quadratic as y minus 7 squared, correct?
Yeah.
So now solve that for y.
So when you take the square root of both sides, plus or minus the square root, yeah.
And then solve for y. You get plus or minus the square root of x plus 7. Now, because this is certainly an answer, but it's not a function.
Yeah.
Now, because they said that, I guess it is an answer. Well, you sure the restriction was x is greater than or equal to 7?
Yeah.
Okay. Interesting. Do you have answers on these?
No.
In other words, I don't see what prevents us from saying the answer is y equals plus or minus square root of x plus 7. Despite that domain, is all that tells us is that x is greater than 7, it can still be the plus or the minus. Now, if I go back and maybe instead of switching variables first, let's do something. Y equals x minus 7 quantity squared.
That wouldn't change anything, no.
Well, I think you're right. I'm just not sure what the purpose of stating this domain restriction was. The only thing, let me show you a different way to do this problem. May shed light on it. Typically with quadratics, when you have a quadratic, you're going to have a problem. Okay? And the reason is that when I go to solve this quadratic, it's not usually very easy to solve. In other words, how do you solve this quadratic for y? Well, I could do it the way we did it, but there's another way to do it. And that is to treat x as a constant, which means I can now say this. Let's see if we get the same answer. I'm a little curious. If I treat x as a constant, that's what I have. Okay? You with me?
Yeah.
Well, now I have a quadratic equation that's equal to 0. I can solve for y by using the quadratic formula. Let's see if I get this same answer. I bet I do. So y has to be equal to, using the quadratic formula, minus b, that's 14, plus or minus the square root of 14 squared minus 4 times 1 times c, and c in this case is that, all divided by 2. I'm betting anything that 4 times 49 is the same as 14 squared. 4 times 49 equals 196. 14 times 14 equals 196. So this whole thing turns in to that.
Yeah.
However, this is a much more difficult concept to see. In other words, it's not very often in math where we take the x variable and we treat it like a constant. And yet that's what I did when I did that step right there. and I combined it with the 49 because the 49 was the constant. And now, once I have it like this, I can apply the quadratic formula to it to get this, which is the same thing as that. So this is definitely the answer, plus or minus square root of x plus 7. I'm still a little puzzled as to why they put that restriction on it.
Could it just be because they just wanted to just add it just to confuse us, or?
No, what it leads me to believe is that when they say x is greater than or equal to 7, well, after we switch the variables, that means y is greater than or equal to 7. Okay? And
Yeah.
for that to be true, we could not have this negative sign here. In other words, the answer that they probably are looking for is this. Because notice that the negative sign would make y less than 7. Because this is always going to be a positive number. If I put a negative sign in front of it and add 7, I'm always going to end up with a number less than 7. So I suspect that this restriction that they put on x falls to y, and instead of our answer being plus or minus square root of x, it's just plus square root of x plus 7. Almost certain that this has to be the answer, and it's because of that.
All right.
Even though if you look at that answer, well, there's nothing that states that x needs to be greater than or equal to 7. We could have it, as long as it's positive, it would be fine. It could be 4 or 5, and it would be fine. But because we switch the variables, this domain issue, and that makes sense, because when you're dealing with inverse functions, basically what you're doing is switching the domain and range. In other words, if I have a domain and range for that function right there, then my domain and range for my inverse function is the exact opposite. So if they're telling me that x has to be greater than or equal to 7, then that tells me that on the inverse function, y has to be greater than or equal to 7. And if y has to be greater than or equal to 7, it pretty much eliminates the negative option. Has to be plus square root of x. So the more I think about it, the more positive I am of it. Because of that. It's very important to remember that when you're talking inverse, the domains and ranges switch totally. Replace one another. So when they gave us this domain restriction, it ends up affecting the y at the end. All right, what else? You said there were 3.
Yeah, so it's like the one we did 2 weeks ago. It's f of x equals 2x plus 1 over x plus 3. Like, I still I can get to one point.
This only has one troubling step. So what's the first step?
Multiply both sides by, or no, flip them.
Switch the variables. Right?
Yeah.
Now, how do I solve that for y?
Multiply both sides by x plus 3.
By y plus 3.
Or y plus 3, yeah.
Okay? Which gives me what's the next step?
Is it?
Get rid of parentheses. In other words, the 2 things that I let rule almost always is get rid of denominators, get rid of parentheses, get rid of exponents. When you're solving an algebraic equation, those are always good things to do. So how do I get rid of these parentheses?
You multiply x by y plus 3.
Now this is the tricky step, the next one. This is the one that always gives people trouble. We are trying to solve for y, correct?
Yeah.
We want to get every single term that has a y in it on one side of the equation, everything else on the other.
Okay.
That's the thing you got to remember. Which leaves us xy minus 2y equals 1 minus 3x. You see how I got that?
Yeah.
Okay. Now we're still trying to solve for y. This step is also a bit tricky. These are easily the two trickiest steps of this whole process. How do I solve for y?
Factor out a y.
That's it. Always is going to involve factoring. Now the last step is easy.
And then just divide both sides by x minus 2.
There's your inverse function.
Okay.
Okay?
Yeah.
And this is probably going to be as tricky as it gets for you. Are these kind of hyperbolic functions? These are called hyperbolic functions, where I have, a variable in the numerator and the denominator. So every one of these, solving for the inverse, is going to involve this exact process. Once you switch the variables, distribute, you're going to have to get the y's on one side, factor out a y, go from there. Now, the previous problem was maybe a little trickier, actually, because of this domain restriction. This is probably as hard as you're going to get in pre-calc. I doubt, I might be wrong, but in other words, if I'd have said that that was 48 instead of 49, or if you'd have said that, this problem can only be solved using the second method that I solved. In other words, this term right here has to be 48 minus x. And then you have to use the quadratic formula to solve that for y, treating x as a constant. The only reason we didn't have to really do this technique on this problem was because it factored into a perfect binomial square. In other words, it was x minus 7 times x minus 7. So we were able to take the square root of both sides to solve it.
Oh, okay.
It was an easy problem, although this domain restriction made it a little tough because that's what let us get rid of the plus and minus sign in front of the square root of x. But if this was your problem, nobody would know how to do it, guaranteed, except you at this point.
All right.
Okay? Because nobody figures out how to do this. By that I mean nobody comes to the correct conclusion that once you've switched the variables, you have to treat x as a constant, like it's a number, meaning it has to be combined with whatever constant is there. And that's why this was my constant, 49 minus x, or in this case, 48 minus x. But you can always solve these using the quadratic formula. And the typical inverse answer, the reason they put that restriction on it is because if I have a plus or minus there, that's not a function. It's an inverse relationship, but it's not a function. It doesn't qualify as a function because it fails the vertical line test. And they didn't want to start talking about inverse stuff that wasn't functions. So they put this domain restriction to eliminate the plus or minus. And now if we have just the plus, that is a function. So that is the inverse function, and you can call it that. If it were plus or minus, without that restriction, it would be plus or minus. It would still be the answer, but it wouldn't be a function. It would be the inverse expression. But you couldn't call it an inverse function.
Oh, okay.
This actually sounds like a very subtle distinction and stuff, but it's not really. If you remember your trig, and when they talked about the inverse sine function or the inverse cosine function, they always had to restrict the domain. When you're talking about the inverse sine function, you've restricted the domain from minus pi over 2 to pi over 2. Because only by restricting that domain does the inverse become a function. Otherwise, the inverse does not pass the vertical line test. You know, if I take just the entire sine function and reflect it over y equal x, I get something that looks like this. Well, that's not a function. It doesn't pass the vertical line test. So only by restricting it from there to there, in other words, in that part of the domain only, it's one-to-one, and its inverse is a function. And that's very important that it be a function. It's hard. Inverses don't have a whole lot of value unless they're functions. So that's what's going on here.
Oh, okay.
But yeah, if they ever give you one like this, keep that little trick in mind about treating x as the constant. And of course, whenever you're trying to solve a quadratic, you want to put one side equal to 0, right?
Yeah.
So the only way to do that is to bring the x on the other side. But here's the tricky part, is combining it with the number, and that is c.
Okay.
Okay? So you can solve even the hard ones, but I doubt that you'll have to. The fact that they didn't give you a hard one here, that they made it a perfect binomial square, tells me that they're not going to make you do the other kind.
Yeah.
Where you would have to use the quadratic equation. What else? You got any others, Mitch?
No, like everything else I could get except the inverse functions.
Okay.
I just couldn't understand.
Okay, and you do understand, let me just say one last thing about inverse functions. You understand that the graph of an inverse function is the reflection over the line y equal x. Well, what is that line? That's this line right here.
Yeah.
If we take this red graph and reflect it over the blue line, that's what the inverse function will be.
Yeah.
And
yeah, I get how to graph it. The graphing part's not hard.
Okay. And solving it is actually pretty easy too. Just always use those two steps. And I recommend people don't mix those steps up, even though you could. In other words, you can do them in either order, but if you stick with the same order always, it makes it easier to remember. So I always tell people, switch the variables first, then solve for y. And if they give it to you as an f of x problem, like they did on some of these, immediately use y instead of f of x.
Okay.
Because when you switch the variables, you don't want to switch the f of x. You want to switch something called y.
Yeah.
All right, Mitch. Well, if you don't have anything else, I'll let you go.
All right.
All right.
Thank you.
Talk to you next week. Bye-bye.
All right. Bye.